Alright, so we're going to review all of our topics here within Karel. Those are included right here. We have our basic definitions of objects and inheritance, and then loops, conditionals, variables, and finally arrays. So that will be our goal, to kind of go through all those quickly. Alright, so we start off with the idea of our structure, right? So we have classes that we define. In this case, we have BeeperBot. This would be our object, and it would have the ability to both do things, which are methods, and then we would have the data attached to those as well. And then we also have set up our driver, and so our driver is also known as the client, and this is the thing that uses the object. So it actually makes the object, it has the new declaration in there. That's where you would have the mechanics of the object being actually used. We also, so this is our kind of, we look inside our driver, right? We can see this is our declaration, right? That's the type of object that we're creating. And then this Billy is our variable name. That's our reference to that object. The new tells us to go ahead and make a new object. And then this calls the constructor. So this is defined within our class and tells us how we're actually going to make this object. In this case for Karel, right, we have the street, the avenue, the direction, and then finally the number of beepers. Alright, this would be what our class looks like. So this again is going to be our definition. We see we have our reserved word class. We build on this class called robot. We'll talk about that more in just a second. Again, this is our constructor, public BeeperBot. It's always going to be the same thing as our class name. The other thing that's different is there's no return type. Okay, this would be our method. So public void find all beepers. Public specifies that the client can, or the driver can directly use it. Void means nothing is returned. If we have a return statement, we'd have to change that. This find all beepers is our method name, and then finally inside the parentheses is where your parameters will go, but in this case we don't have any. Alright, so we talked about objects from the beginning. Again, they have the ability to do things, which are methods, and they have attributes, which are data, often are variables. Alright, and so we define them by a class, and then we can build on other classes by extending them. A constructor, so we have to specify a constructor. It's always going to be the same thing as the class. In this case, it would look like this. Now, when we say we have to specify a constructor, it is possible that if we leave this part out, so we don't specify BeeperBot, we get what's called the default constructor, and that's basically empty. So it would have nothing in it. So Java will provide a constructor. In general, we're always going to provide our own constructor, but if it's not written, there will be a default constructor that's actually provided for you. Okay. This is in the main. This is making an instance of it, and again, you can see it with that reserved word new. That's what it's gonna look like. All of these are built on what are called universal markup language diagram, or just a UML diagram, and BlueJ provides this for you as well. We want to understand kind of what it's telling us though. So in this case, we have names that give it away, but this dashed arrow means that Harvest Driver is using an instance of the class below it. So it's using an instance of Harvester. It's not the same as an extending piece, so we'll look at that here in a second. But we have the ability to use it, and we'd see that declaration in there, and that's what that dashed line is going to signify. If we extend a class, we would have the solid arrow. In this case, we don't see the extension arrow. That doesn't mean it's not a subclass. We don't see the extends robot because we haven't written robot. This is brought in our import statement. So when we import Karel the robot, we have that piece. So it's not a class that we can actively manage, which is why we don't see a little box here with robot on it. But it still makes it a subclass. It's still there. We still extend it just like we would before. Right. This is our UML diagram for our extension. And so in general, we have a subclass which extends a superclass. And what this means is the superclass starts off, let's say it has some method. This is called test. All right. The subclass can do everything that the superclass can do, plus whatever else it has the ability to write for itself. So if it writes test2, the subclass can do test2 because it has it directly written. It can also do test because it's been inherited from the superclass. So everything filters down in Java. You inherit from everything from above your superclass, plus whatever else you write specifically to your own subclass. We also have the Karel API. You can look at it. It shows you kind of where your classes are. The things to keep in mind is for our diagrams, we have your robot, which is our superclass. It has the methods like move in it. And then we never see this one, but we have robot, which is a subclass of your robot. It can do everything that robot can. Your robot can do. It also has like your Boolean directions, so facing, east. It has those additional things with it inside. And what we would usually do is we would extend robot. So this would be our class or our bot. So we'd be able to do everything that robot can do, and by default, everything that your robot can do. All right. We have the ability to override a method. So this is if we extend another class. So we're a subclass, right? And we override an example, and we rewrite. So another way to think of override is we rewrite that method. Okay. We already would have the ability to move from our robot class. When we rewrite it, this is overriding. Now the super here is going to reference the class above it. So if we took the super out, if it didn't exist there, what we'd really create here is an infinite loop. And so being able to have super in there is going to allow us to actually call the move method from above. So in effect, what this is going to do whenever we do this bot.move, it's going to go to this method here, and it's going to end up moving 2 times. It's just going to use the superclass to move twice. Overloading methods is when you see the same method name again, but it has to have a different parameter type. So again, what we're looking at here is this method name here, move and move. The difference is that this takes a parameter, and that's method overloading. Now, it would not be able to move like this. You can't just change the variable name. So there's no way to differentiate from the driver position between X and steps. So this would not work. That's not going to be something that you can do. You'd have to change either the data type or you'd have to change the number of parameters, and that would be an example of overloading. Method decomposition, we've been doing this from day one. This is really where we just break a problem down into submethods. We specify our algorithms. We want to avoid long run-on methods and really try to think about how we solve something from a top-down position. All right, we've done conditionals in Java. We've seen these before. What we really have here are our operators. The key with this is kind of operator precedence. These are our positive and negative values, like -3. We have then our multiplication, division, and remainder. This is addition and subtraction. And then we test for our equality. This is a test for equality, right? So it's asking the question, are they equal or are they not equal? Okay, not assignment. Assignment is our last one, which is actually setting a variable equal to a value. That would set that variable x equal to a value as we go through there. Okay, we have the ability to return statements from a method header. So again, this void type, so there's no return statement. A Boolean type means that you have to at some point return a true value. And after something is returned, that's it. There's no executable code below this. So if you had something like this, like y equals 2, that would actually kick a syntax error, as once something is returned, it's done. The method won't progress. So that won't compile as you try to write it. All right, we looked at notes for loops and while loops, so you can review those, but they're pretty straightforward. Your for loop, again, has 3 components, the way that we're going to set it up. We're going to initialize a variable, so maybe something like we'd say int, we declare it there, x equals 0, and then we'd have some tests while x is less than 10, and then we have some increment, that's x plus plus. It could be something else, it could be x plus equals 2. We could subtract stuff, whatever we want from there. But that would be our incrementer. And then it's going to repeat that many times. Now, it is possible to get into an infinite loop here. So let's say that we, instead of plus plus, had minus minus. So what we would do is we would start at 0, right? 0, -1, -2. We just keep going. And this condition, x less than 10, is always going to be true, which means we would never get out of our infinite loop. This is another example of it. We can see this would just move 5 times. If we could build the table, we'd see that that's what's going to happen. All right, well, we have a while loop. This is often called an indefinite loop, right? So an indefinite loop means we don't know how many times it will run. It might run once, might run twice, might run forever. But basically, we have some condition that has to be true. So in Karel's world, that could be while next to a beeper. Right, so as long as the robot is next to a beeper, we're going to continue to execute some task in here. And as soon as that's not true, this is going to stop and your loop will end. This is an example of that while loop. This is a compound conditional. Okay, we have an AND statement, which means for this to execute, that has to be true and that has to be true. We have to be a little bit careful. We have that not there negated. So what really is going to happen is we're going to, let's say that this was false next to a beeper. When we take the negation of that, it's going to become true. And then if I look at true and true, that whole output would be true. And so we'd enter the loop and we'd finally end up moving. As soon as one of those would be false, we would exit that loop after it's run through its whole loop, and then we would be done. All right, we then talked about variables. The key with variables is figuring out kind of what their scope is. And so we have what are called instance variables. Instance variables are declared at the top level. What that means is they're accessible to all methods. All methods can directly access, manipulate. This is kind of like a global variable for the class. You have two options on these. You have public versus private. All this deals with is how the driver can access. So if we have a public variable and we were to make a declaration of this type of class, you could directly call, let's say it's just bot. You could directly call bot.steps. Okay? There's no parentheses here because it's not a method, it's a variable. So you could directly call it. If you tried to do bot.blocked, what you would find is this would kick an error. So it would not compile. It would basically tell you don't have access to that private variable. But that's only in the driver. That's not in the class itself. So everything in this class would still be able to access both of these variables. It's only as you're using it from a client position. All right, we have local variables as well. So this is declared in this method, so it can be used anywhere in this method, local variable. So you can see we have beepers in here, but as soon as this method ends, so once this is reached and we're done, this variable goes away and we wouldn't have access to it anywhere else. And every time this method gets called, what we would see is, so every time we have local variable called, we get a new copy basically of that variable beepers. It gets reinstantiated, redeclared, but it gets recycled at the end. So that's one type of local variable where it's declared in a method. We also have, where we have our instance variables. So if this was an instance variable, right, we would look here and we'd have to say, all right, it's not declared. I have this variable steps. It's not declared within here is a parameter or in the method. So it must be an instance variable. Anything we change here is going to basically, in this case, stick to the class level. So if something else uses steps down the road, it'll carry through with that change to it. All right, so we also get these methods as they get passed through. Okay, if we have different declarations here, so I have some int value, I have some other value, and I have some Boolean value. These are all separate variables the way that Java would look at them. Because they're declared as parameters, they are local to each of these methods, which means that they don't cross-reference each other. And we can see that because I have some Boolean data type and I have int data types on those ones. So we're not going to be able to change these. If we change value to 37 here, that does not go through and update the other ones. So be a little bit careful just because of the naming conventions. We can provide access. This is, again, we can work through how that would be implemented. We've done this before. And you see with the comments here that when I look at this, what I see is this piece here, vern.steps. Steps must be a variable. There's no parentheses after it. And if it's going to compile, then it has to be a public variable. Okay? We can see this one is commented out, but that variable blocked, which was private, is not going to allow access, direct access through the driver. And the way that we know this is a driver is it's actually making an object. It has that declaration and it calls new on that object. Okay, here's another one with local variables. Again, it's declared in there, it will just exist in there. This is another type of local variable where it is a parameter. So again, it looks a little bit strange, but it's declared right here, which means when this method ends, that variable steps is gone. There's no change that will stick to anything else in there. We talked about remainder. We talked then about lists. So this is our final thing, which is our Java arrays. So some of the things in Java arrays, we have our declaration. One thing that's really different with these arrays than maybe other languages are we have a fixed size. So once we declare it to be size 10, what that does is it gives us 10 things, and it gets set to nothing. So if we have an array of ints, these would all become 0. And what we'd have to do is manually go through and manipulate them. If we had an array of Boolean values, they'd all be false. An array of objects, they'd all be null. All right. So how do we actually access information? So what we have for an array are indices. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I count that right? Looks like it. If we wanted to pull out the 2, what we'd say is beepers 2. That's going to give us a value that would actually return and give us, sorry, I did that wrong. If we were to actually want the 2, we'd have to put in the index, which would be 4, and then that would give us the value of 2 that we could then use. So that's how we'd access it. Pretty straightforward and pretty standard syntax. We can loop through it. One thing to keep in mind is it's really easy to get an out-of-bounds exception with arrays. So if we set this up, this is our beepers.length. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 things. This is 11. The last value of I that will execute is when I equals 10, which is going to be your last index. So you're going to guarantee you don't get an out-of-bounds exception if you use beepers.length. Again, keep in mind this is not a method, it's a variable, and again how we can tell is there's no parentheses attached to it. Alright, we then finally talked about two-dimensional arrays, and what we have here are, if we think about an array of arrays, we have, in this case, 3 rows, each containing 4 items. And so 3 rows with 4 items gives us our 3 by 4 array. And this are our number of rows, 3, this is our number of columns, and that's how we declare it. It's the same as matrix algebra. You would go your rows and your columns as we declare it. And so we have our first row, our second row, our third row, and then as we make the whole table, we put those all in an array. And that's what this would look like as one declaration. And what we can see is if we look at the length of this outer array, so the length of the outer array is 3. It has 0, 1, 2. Those are the indices. And then the length of this first thing is 4, and that becomes our number of columns. So that's helpful as we start to set up our loops to go through these. If we wanted to pull out values, we'd have to have a double index. We'd have to talk about the row and the column. So this is what I was talking about with looping through it. The array.length is the outer array. So that's that piece. That's going to be 3, which is your number of columns. And then if you take the 0th index, so that one there, and the length of that, that's going to be 4. That's your number of columns. And that's a good way to work through it and avoid your out of bounds exceptions. This is going to be the actual value in the array. So we will always go row, then column, and that will be pretty straightforward. All right. And then we use these for the planter class. We had a driver where you had some two-dimensional array. We looped through it to make sure that we could actually instantiate and utilize a two-dimensional array. Alright, so that's it. That's all of our Karel stuff in kind of a real quick nutshell here. Go back through, make sure that it makes sense, look through your notes, look through your exams, and you get a page of notes for the midterm. Good luck.